Okay, so it feels like it was quite a while ago, even if it was only a week and a bit. But last month we made this simple sliding tile puzzle game from scratch, using only some like Zig wrappers around OpenGL and GLFW, and then we uploaded this to itch. To this page, where like we can download it for Windows here. It's just like a simple 1.8. I now want to get this on the web as a how to describe it? Just like playable in the browser. But there's some very big caveats. The first is that at no stage are we going to be writing any JavaScript. We might be calling JavaScript functions, but we'll be doing so from within Zig itself. We want to make like a static website, just like a WASM, put everything like as much as possible in the WASM, get that there, and then that way, doesn't matter if someone updates a framework on the internet, doesn't matter if there's some like NPM server or whatever like goes down, the game will always be playable. It will just be a static site. So last year, I think in August, I did like the first experiment into this with this like Zig WebGL WASM example, where we got that screen blinking, we got a fractal going, and the fractal that was going here, it was completely static website. So I think the first thing I want to do today is to see what it's like to actually upload a static website on itch. There was some drop-down option last time that said it. I just want to know, like in my mind, what's the transition between like the web page that has the static web page that has the game versus what it looks like on itch. And then once that's done, we can then begin the process of actually porting this thing to the WASM. The porting it should be somewhat straightforward. It's going to be it's going to be slightly involved in that. We'll have to change some of the rendering. We rendered this with OpenGL, so we had functions like geo.like attribute, where it was like the vertex attribute, vertex attribute pointer, all of this kind of stuff. All of these GL functions we're going to have to replace with the corresponding WebGL ones. So basically they should kind of be the same. I don't have much experience, really any experience with WebGL, but let's see. We can just just like browse the code of the fractal version we did, fractal.zig, all this time ago. Okay, it was 200 lines of code. About as long as I remember it being. Okay, yeah, we do actually have a vertex attribute pointer and some other stuff. Okay, basically kind of looks like the same. So yeah, we'll need to do that stuff over. Likewise, the timing that we did within this, we have some time. We have like a bunch of program timestamps. We'll have to, there'll be like some small things to port, but otherwise it should be straightforward. Like, yeah. And then, once, this is basically just a proof of concept, but like a proper proof of concept, because, our game involves like several shaders, textures, timing, And so like if we're able to port this game to, if we're able to just make this game like a single WASM, get it onto a static website, we should basically be able to do this with any 2D game and probably any 3D game as well. And then that will be great. Yeah, I think at the end of like the final stream I did for this project, we saw the horror of what happens when you have games on the web that are not static, that take like 10 seconds to load with like the Unity DLL, or in that horrendous case, like that, what it looked like was like some like Android port, like a loading bar took like 5 seconds to load, and then that just produced another screen with a different loading bar. Like absolutely not. We're never going to do that. So we want to improve the quality of software, not make it decline. So so we should check out then, actually before I kind of do any of this stuff, a new Microsoft, in a strategic decision, decided to spend like employ like 500 people, probably like thousands of people, to work on their like latest AI instead of updating this file explorer, which is a total piece of crap. But it's okay. One person working on their own said, I can just completely rewrite the Windows file explorer and make something better than however many people at Microsoft could do it. And so we're going to download this and then start using this. Yeah, we want to get the standalone free beta. Put this in software. Pilot. Okay, and then oh great, here it is. We use this as a standalone, and now we don't ever have to use this again. Thank goodness. So we want to add this to the path just so we can let's see, was it pilot? Yeah, let's rename this file pilot. This is way too small. How do we? Okay, let's change. Okay. Okay, so now we can like launch it. Great. We want to get rid of that. Okay, we want to increase the size of the text. Or font size, here it is. $12 looks good. Great. Okay. Yeah, that kind of part done. So yeah, we want to go to our WASM examples. I want to open up a terminal. How do we do this? open a terminal. Okay, so what? So we want to just build our fractal example again, which was, I guess, zig build fractal. Okay, done apparently. So zig out, then. All right, the fractal WASM is here. Right. Oh, wait, I'm gonna have to like launch the gonna have to like spawn like the server in order to do it. What is it? Like Python http.server. Okay. Local. Okay, whatever I had there was probably the right thing. Okay, great. So yeah, the fractal example, unsurprisingly, still works because by construction, it's all just contained within a WASM. So now we want to try getting this on, let's just try getting this like fractal example on itch. And once that's working, we can then proceed to port the game, the sliding puzzle game. Even so, I want to just, if we view like the source of this page, what is the zig JavaScript bridge doing again? Right, that's trivial. We could almost, we don't need to touch it. Yeah, it's running, all of this stuff is automatically generated, and then this stuff is automatically generated as well, and all it's doing is just getting the WASM, and that's it. So, yeah, everything in there should be enough. So let's do like a test. So let's create like itch fractal upload test. Okay, we'll copy everything to there. Get rid of that clearly. We don't need this blinking screen WASM. I think that's it. And oh wow, would you look at that? This isn't not even half a megabyte. This is like, our game will similarly be very small. And then we want to, yeah, let's just try out. Try it out here. Itch.io is on YouTube. Okay. So yeah, so we want to do, how do we do this dashboard? Create new project. Title, test, fractal upload, WASM upload. But we want this to be private. Only those who edit the project can view the page. I guess that's fine. So yeah, just for testing. Yeah. Don't make public. Okay, this is the part where we want to test it. So instead of no, like, oh my god, Java applet with JAR that will be played in the browser. No. Oh, you have a zip or HTML file. Okay, so upload a zip file. Why is this font so bloody small? Upload a zip file containing your game. There must be an index in the zip, or upload a single thing that contains it. Okay, so we do have index.html here. So I guess we want to zip this up and I guess add to archive. Okay, when it says zip here, presumably this isn't 7-zip, so it's gonna want this like less good compression algorithm, but okay. That should be done. Yeah. Oh yeah, it's only about 0.1 megs, and then let's overload that. Wait. Why would anyone, how could anyone possibly upload like a 1 gigabyte website? The scope doesn't feel correct. So yeah, we want to do this one. Okay, so then we'll see. Why would itch need Dropbox? Anyway. Okay, so will this automatically make the game? Let's see. Okay, and there's nothing. Maybe? Oh, itch.zone. Okay. Let's save. What's like itch.zone? What JavaScript is this running? Okay. So yeah, so clearly it's here, but so this is good. What's Kagi doing? Anyway, it's okay. So how is this different? What's it doing? Is this? Okay, so we're gonna have to figure out something with the resolution. Okay, so does itch have a fixed width for which it runs these things in the window, or do we get to choose it ourselves? This is unclear. So does itch HTML upload like window dimension? Okay. But hang on. We should just check like the speed of this. Okay. So I'm a bit worried that we press run game and like it's like paused. Okay, like that. That's the acceptable speed. That's what's meant to happen. You press run game, and as soon as you click it, the game is there and loading. But why does it sometimes pause? Anyway, we'll just have to. Anyway, okay, there are some documents. How do I set dimensions? Okay. Positive. Like, let's just remove like the search term unity from any of these results. We're not doing it the noob way. We're not doing it the slow way. And view your Rosebud game. What's Rosebud? Rosebud.ai. Yes, I'm sure high quality games are gonna get made with that. Let's just remove the search term Godot as well. It's not. Okay, this should be enough to find out results. So yeah, interesting. Okay, let's actually just adjust the size of this. Okay, so the dimensions do seem to be fixed. It is just like currently a single pane. Okay, this web page gives me no information. Okay, so yeah, assuming 960 on desktops. Specify the dimensions when you upload it. Really? Let's check that again. Yeah, where's the dashboard is what I want. Dashboard. Edit. Oh, there's like more? No. Oh, here it is. Great. Okay. This. Okay. We want this stuff. Yeah. Okay. So we want to view page on one tab. Move it this way. Great. Okay. Working. So here we want to do. No, I think we want to embed in it. Like the couple of examples we tested last time where we did press like click to launch in full screen, like something about that feels incorrect. Like I feel like you should at least communicate to the player beforehand that it is going to be launched in full screen. And I didn't see any way of each doing that. So we're going to just keep the embedding page. Auto detect size using HTML only. Okay, so this is good. We can actually just set it to what we want, which is quite useful in our situation since our game is 100 by 100, and there's so many windows here. Yeah, let's sliding puzzle Z out. We set it to be 1,000 by 1,000, so we can just make this one to be 1,000 by 1,000 as well. Maybe we should shrink it to like 500 by 500. Because like I don't mind the current width of this as it is. I don't want it to be huge and taking up the entire screen. We might just make it 500 by 500. Okay, and then say I save this, and then we just refresh it. Yeah, like why does it like store like this, and then only when you reload the page does it happen? This is really concerning. It may just be like the JavaScript that I'm blocking, but even so. I wonder. I mean, is there any way to test this? Because yeah, it will not be acceptable to upload this if after pressing play game, you need to like refresh the page and then do it again. But yeah, I wonder if this is. We might test this by actually making this public for a moment, and then if we can switch it off, and then viewing it via a different web browser and seeing what happens on it. Or we can do this restricted only, or owners and authorized people can. You can give access by generating download key. The page will be unlisted. Also allow a password to view page. Okay, let's just make this like the worst password you could choose, like fractal. Okay. So this is the page. So now if we say like we go on like Microsoft Edge and then we try and hello. Okay, let me try this. Never. Okay, and it works. Good. Yeah, it must have been some JavaScripting going on in the background. Okay, this is good, and then this is why we've gone for all of the effort. Like we press run game, bam, bam, it's immediately loaded. No rubbish loading bar or any shit like that. None. It's just it loads immediately. So, okay, so I think we can now we've now solved this part of the problem. So when we actually convert this to the static website, we're going to have to adjust the dimensions to 500 by 500 instead of 1,000 by 1,000. But otherwise, it's very straightforward. We just use the single Zig library, the JavaScript bridge, from that produce the automatically produce like Zig will compile it to the WASM. The Zig build system will generate all of the other wrapper HTML crap, and then we zip that, upload it to itch, and it's there. Okay. Okay, good. So let's adjust. Let's delete. Let's adjust the the visibility to like draft, and then yeah, and then we can get started. So this is good to know. This is good. I was worried that there was going to be pain involved on the itch side, but when I say pain, I mean pain. Having to like crawl through some itch JavaScript library or something, but thank goodness we do not. Okay. Okay, so yeah, where to start? Okay, so in our game we have, so with this thing here, we're drawing some geometry and rendering on that geometry this fractal shader. Yeah, so I'm in two minds about what to do. One is to, one is to just make an example where we render a rainbow triangle. Let's even make it a rotating rainbow triangle via the same processes, JavaScript, as we've done here. The other is just to immediately try and start porting the game. Since it's been more than about 6 months since we did all of this, I've forgotten most of it. I remember there's being dealing with like the time on the JavaScript side was like a total pain, but I think that was a kind of logic error maybe. So I almost just want to refamiliarize myself with the library first. Also as well, like all of our projects should be open source, but I think that yeah, we had to do like the GitHub button pushing to make the MIT license last month, but that was the first time we had done it, so we should do that for this project as well. Yeah, when it says like other here, like what does it mean by like other? Yeah, we need to like we need to clean this up. Okay, and then okay, yeah. So let's. To me, this suggests. Yeah, the thing to do is just for the remainder of this stream, we render a rainbow triangle that's moving. This will will get us comfortable with all of this stuff again. And then also fix up all of the licensing stuff, and then after that we'll just be able to kind of hit the ground running with that rotating rainbow triangle example and import the game. Okay, so let's go back to the build system we had for this. Oh my goodness, so many to-dos everywhere. Okay, does this even have a build.on file? No, we should change this. Okay, maintenance is like part of the software engineering code. It's just this is what happens. Okay, so yeah, so we're gonna do so we want to like expose this as a module and call it from within input. Maybe it's good just to read all of this again. We'll do that. So yeah, this creates bindings for accessing JavaScript from the WASM. Yep, we know. Yeah, something that's actually type checked versus like this, even if it is a bit more verbose. Okay, yeah, functional, ready to be used in other projects. This is absolutely true. WASM has restrictions on the function API surface and how references to the runtime environment can be stored. So to access JavaScript functionality from Zig, you must create a function in Zig which is friendly to call. That's just with like extern. A function export, and a function in JavaScript which translates the call. This isn't too bad, but the JavaScript API service is large, has a lot of variadic functions, and accepts many types. This is the true killer. Yeah, the result is a programming loop. Just wanting to write code slows down writing a large amount of ill-fitting boilerplate. Yeah. So I don't think we ever looked into this Go package that inspired this. Maybe, I don't know, maybe sometime in the future we'll look at Go, even though, well, I mean, Go is garbage collected, so I'm gonna have to pass. Wait, Go like blocks on the main thread, or good grief. Yeah, no. Okay, as arguments or return types to be passed into JavaScript. Okay, so 4 or 8 byte signed integers, 4 or 8 byte floats. That is it, okay. Conf times will be passed as F64. Oh yeah, these handles. I remember these like handles happening a while. Const handle as arguments but not return types. Okay. Yeah, okay, whatever. Okay, so Where to begin? Given the option between trying to modify what's currently in our like WASM examples versus making something kind of new, doing the build files, all of that stuff from that, and then porting it across, I kind of just want to do it fresh, and then we'll make like the rainbow triangle example fresh. When that works, we will have a priori figured out how it works, and then we can translate it over. I don't necessarily want to be doing like trying to figure out how this works with like the existing stuff. It's a bit cluttered. This said, we still should check out what we did. So okay, so I do see module here. So we did get this from where? Oh, it's a single file. But this has its own build files. Yeah, we should be calling this with like the dependencies and everything. Yeah, okay. Let's yeah, let's save this as a like separate folder. Okay, so let's go into temp, and then we can just say yeah, Zig JavaScript bridge Scott Redig sort of clone. Okay, stuff's there, and then I don't like when I say like file, when I alt tab file, it like does this different thing. Let's change like the file pilot exe to just like fp exe. No one can spell it. Pio. There it is. Let's call it fpio. Pilot. Okay. Yeah, let's see it. Okay, so yeah, we're gonna have to copy this into a new thing. So let's do like what should we call this? Like rainbow triangle WASM or rainbow triangle. We are going to eventually port this, so well, we'll just create a new project we'll create like a separate port for this lighting puzzle, and then the first thing we'll do in it is to get the rainbow triangle working, and then we'll put stuff over. So so we do sliding puzzle WASM, or maybe just like port of sliding puzzle to WASM. Okay. So now we want to make a new directory called dependencies. Actually, I keep on doing this a lot, so we should start that. Pin command to the top, yes. See, like Windows, why couldn't you just like do that? Like, and now I was able to set a custom option within 5 seconds. Now whenever I use this, it will take me less than half a second. Zig JavaScript bridge. So now, okay, weirdly, why isn't like the .git directory, why isn't file pilot showing the .git directory? That's really weird. Yeah, like I can, clearly there's stuff inside the Git, but why is it not? Why is it being hidden? Okay, good. So we'll move all of this, copy all of this here. Okay, and now we can start calling this, but in the proper way. So let's see, in our project, in the actual sliding puzzle one, okay, we have this build.zig.zone, and port sliding puzzle WASM, build.zig.zone. So we'll call this sliding puzzle, we'll call it the same thing, port sliding puzzle WASM. I guess that's the Zig version we're still using. Let's see, current. Oh, I guess, oh, okay, since we're porting this, we're not going to have to use the gamedev Zig library, so we can actually just compile this with 0.13. Yeah, no. Okay, so then this is where we really want to make it clear where that we're using Scott's excellent library. Like the amount of like pain, like time and pain that like Scott has saved us by writing this, like, it would be difficult to measure, let alone quantify. So yeah, so we don't. So here we want. Right, the name of this thing here is what we're going to have to refer to it in the Zig build. Oh hey, Magnevio. No, I'm not. In terms of the operating system, this is just like plain Windows. I'm just using my gaming PC to stream, and my gaming PC runs Windows because most games are made for Windows. And then in terms of how am I putting this via Zig, I guess I'm not sure if you saw earlier in the stream, but many like last August, I made a last August I came across this this library by Scott Redegg, which allows basically somewhat very easily allows you to call JavaScript functions from within WASM. Last year I made some examples. I just made like spawning a screen like this and then like spawning a fractal. Just now at the beginning of the stream, I kind of like practiced uploading the static website that was generated, this thing here, this test WASM, and this is the result. And so basically using I write code in Zig. I call some of this library, and then the Zig compiler, and the Zig compiler alone, using nothing else, turns this into a static website. I just turn those files into a zip file, upload the zip file to itch, and then this is the result. And so there is some behind the scenes, a tiny bit of JavaScript code. It's all automatically generated. I don't touch it. I just basically do everything in Zig. And so, I haven't heard of Blazor, WASM, and Tori before. Blazor, WASM. What is this? A single web page application framework. Single page webs, okay. The C# is, this is a red flag for me, like the net core ecosystem's a bit of a red flag as well. But it's great that I would hope everything like this is offline, so that's good. Okay, yeah, I've never heard of this before. Need look for port it to Tori via Zig, because so much more instructions not work. Tori not like some features. Yeah. So like the good thing with Zig, right, is that like Zig targets heaps of targets. some with its own custom backends. Some is currently using LLVM, but the long-term goal is for Zig to be completely independent from LLVM. And like by default, debug builds will not involve LLVM at all. Long-term, Zig will do its own optimization passes. I highly suspect those are going to actually be faster than LLVM because of the just extra information that Zig encodes, like a stronger type setting system, a bunch of other things. But you still will have the option to use LLVM for optimization if you want. Yeah, but in particular, there's also going to be a like custom WASM, optimized WASM backend as well. I'm not exactly sure what this Blazor is using to compile. Presumably it's using Emscripten, but maybe it has its own custom backend as well. What else is it here? Okay, there are some examples. Okay, and it is fairly recent, I guess. Yeah, but also, what's this Tory? I've never heard of this. Tory WASM. Oh, right. Rust. It's connected with Rust, is it? It's Hacker News. Yeah. Anyway, yeah. Well, one of the reasons we're doing this in Zig is that we don't have to learn anything else. It's just we do it in Zig and that's it. Okay, so ZGFL is, we want to replace this with ZJB, and the path here is now ZJB, like that's what we did call it, right? Port dependencies, yeah. And then that's kind of it. And then for the current stuff in this project, let's just no comment syntax is defined. Okay, use // yes. Okay. Good. Okay. Okay, that's that done. So now we want to make something to call this with. I want to make the rainbow triangle example. So what should we want to do this? It may be good here to actually to check out to just use this like breakout example that Scott Reading did. Oh, why is C# the red flag? Right, okay. It won't be to everyone, it just is to me. I've had bad experiences in the past with versions of C, with basically every version of C. But if I had to sort of rank them, I would say like C's the best. Okay, I'm not going to rank them. Basically like C++, C#, and some other stuff. I haven't had the best time with them, and like I've had some yeah. When I briefly looked into like C#, it was, I had a bad time. Like I much prefer Zig. I think Zig has like a way stronger like uh, um, actually I haven't really used C# long enough to comment, but my memory was just I had a better time using C than C#, and but I'm having like a so much better time using Zig than C. So if I assume these things are transitive, this means that like I'm having a way better time with Zig than I would with C#. But yeah, just a lot of I'm not a fan of object-oriented like programming in general. It has its use cases, but yeah. It's just I think in the way most people use object-oriented programming in practice, the negatives outweigh the positives. But there are many cases where the positives do outweigh the negatives. It's just I haven't seen that many cases of that. Yeah, I've seen many cases of like code that is significantly slower because it was doing something simple. So it could have been written in like many languages, but it was instead written in an object-oriented language, and then the code was bad and it was slow. And I was like, it would have been better in just pure C. It would have been, yeah. But I shouldn't rant. I know a bit about Zig and a bit about Odin and some C. I'm not I don't. It's not like I have 10 years experience in any of these languages. Okay. With C actually, with C it's more like 8 years. But anyway. Okay, so we're doing this build.zig file, but want to check out the example in the Scott Reedy case. So yeah, so let's dependencies. So let's check out what's happening here. So a generated so build a executable to generate the JavaScript. Install it. Then okay, and this is apparently it. But in this example, yeah, this example is where we've already added this as a dependency with the design. Oh, what's this? Resolve target query. I guess that's just setting the target. adding this so we can call it from the code. That line, yeah. Oh, interesting that allocator there is being used. Why is an allocator? Okay. Oh, when was this updated again? Okay, probably has changed a bit. Example entry, okay, this, not sure what this part is doing. Did we even have that in our previous example case? In our own build file, did we have that? We did have that. Oh, okay, we did. I guess we either didn't look up what it was or have forgotten it. Okay, and then this is the one, right, where this exe was generated. We then want to run that. Extract example, add output arg, okay. Add artifact arg. And then all of this is just the steps, so okay, don't do a bin, just have that instead. Then yeah, add that into the directory. And then install the directory, the static one. Right, which contains all of those ones. These are just the minimal files that, yeah, that we expect. Oh, all of this is just sample stuff we can get rid of. Because yeah, I didn't remember that from this. Right. Yeah, we can basically get. We can delete everything aside from. We can delete all of that stuff. All right. So yeah. So let's copy the. God, it's like this stuff is worth it. It's worth just like removing, like, you know, pulling back the curtain, dealing with it. Instead of just building like dependency on top of dependency on top of dependency, just using exactly two, in this case the Z compiler and Scott's library instead of like 100. But it takes a bit of time. Okay, so we want to copy the simple stuff in here into triangle. Oh, but interestingly, this one also has. This already has the Zon. Or what's it using? Oh, right, it's actually saying just go above it. Okay. Yeah, we can copy everything aside from that. Yeah, copy and replace. That's what we want. Okay, so now we can give this a go and build it. Minimize everything. Too many windows open. So which version of the compiler are we using? Yeah, Zig build run. Why? Oh, it's in the build.zig.zon. Microsoft, stop it. What are you doing? Expected paths expression to be a list of strings. C# cross-platform, very quick. No, I push strongly back against the claim that C# is quick. No. I mean, quickness is relative to stuff, but it's also like it's also way more efficient. So like for instance, codeberg.org. So for instance, the creator of Zig, like Andrew Kelly, for like a side project at one time, decided to port the like Sean Barrett's very, very heavily used public domain STB true type. And it's on GitHub, like a bajillion people have like contributed to it. It's as I said, it's public domain. It's kind of used everywhere. But sort of just as like raw C code, it's basically like 5,000 lines, like with comments, bunch of stuff. So like Andrew Kelly basically like rewrote all of this in Zig, basically the same functionality, like slightly different API, but basically the same. And I guess Codeberg here is behaving badly, but from memory it's 1600 lines. So like that's a huge reduction already. Like a 70% reduction in size if it is as large as I remember it is. Yeah, okay, it's not even 1600 lines. It's like 1597. So this alone doesn't necessarily mean it's going to be faster, of course. However, I basically like tested it out, and I made like a small program in this, tested out with the C version. This one was way faster. It was like I think it was nearly like double the speed, and yeah, if like Zig is strictly faster than like pure C, and pure C is strictly faster than C sharp, it means that yeah, Zig is strictly faster than C sharp. Yeah. Now, so it's just like reading 1600 lines of code is much nicer than like 5000. And also Z code is just way nicer to read than C. So, okay, so, but yeah, expected path expression to be a list of strings. Okay, let's just make it like the empty string then. Find one. Okay, file not found. But we definitely said that ZJB is within the dependencies. I'm kind of worried here that it's getting the the direction of the character in the wrong way. Is it just one? Another one? No, it is. It's confused. Wait, now I'm really confused. How is it? Is this not exactly the same thing we did with the sliding puzzle? Is this expecting it to be like a single file? Okay, one thing we can do is just go into the simple example. Well, is it in the example or in simple? Where's this one? So why is it getting confused in our case? Yeah, I'm so confused. Yeah, and I'm so like annoyed about. I suspect it's this like this stupid character. Okay, it may be worthwhile checking out the differences between how these game dev libraries are structured to this one. So if we check out if we check out like GLFW versus versus the port, it should have some sort of artifact. Yeah, where it's like it's installing GLFW is the artifact, so then no, I'm still baffled why it's not finding this. What if we did something really silly that was just to say like we move ZJB out from like under the dependency, just into like this usual directory. And we modify the build file. I feel like let's just get rid of Emacs's. There's too much stuff around. Okay, and then we just open up the build file here. Open up the build .zon file, and then we just say the path here is now ZJB, and now we try building it again. Okay, that time it did work. Oh, so bizarre. So now if we do zbuild h, what are the options? Okay, So we want to do the simple example. Okay, and it looks, there should be stuff within zigout. Yeah, all of that is there, as well as like the WASM. So if we go to zigout bin python http.server server. I need Abner's terminal. I have to. It's gonna be like another year before Mitchell Hashimoto ports Ghosty. I need Windows PowerShell sucks so much, okay, and now this should be it. I might have to like reset these like temporarily cached files and pages. Oh, it's already half a gig. Yeah, let's clear that. Okay, good. Hello from Zig. Okay, this is working. Good. So, yeah. Okay. So now there's this like totally baffling thing. Is it an error with the build system then? That like I've never encountered this problem before. That simply by like moving it inside dependencies, the build system failed to find it. Like what? In either case, we'll just move ZJB to like ZJB dependency. This is so bizarre. Like in other times it'd be curious to like track down this bug, but since Zig 14 is like literally being released within the week, who cares? This might just already be fixed. This may have already been fixed by then. Okay, so yeah, so the path here is this dependency. Okay, let's just like remove everything from the cache and from zigout and try again. What was it? Zig build exam. It's like Zig build simple. Okay, this seems to be working fine. Okay, so now we want to do the rainbow example. there's so much crap in here. Let's remove everything that's like that first. So I think now we want to replace, we now want to do the rainbow example. Now this is building, so we're going to have to modify this a bit. First off, we'll make like an example called like rainbow triangle. We'll put stuff in there. Make this executable rainbow triangle. The source will just be rainbow triangle main.zig. Every time we see simple, we'll replace it with rainbow triangle. Oh, Zig might whinge about that name. Simple to rainbow underscore triangle. Why is this called extract simple when this doesn't seem to be tied to it? Oh, okay. Oh, I see. Okay, this, the generate.js.exe must itself be run on the binary. It's yeah, we'll just get like continue doing this. We should just keep the underscores and tabs the same. I was going to get confused. Okay. Okay, so now we should be able to copy what's in our, say, like fractal example into here and then get it building. Okay, yeah. What? I need Ghosty. I need Ghosty for Windows ASAP. Carousel is so bad. I mean, what's this like? I press Control K, which on every single operating system means clear the line, and then Windows spits out like a stupid caret sign K. It's embarrassing. Okay, so zig build rainbow triangle. Unable to check stat file. File not found. Oops. Okay. I call this main. Oh, but now it's done. So good. Zig out. Then Python http.server. Okay. Oh, file not found. Oops, why not? Is it another like cache thing? Oh no, it's expecting simple.wasm. Okay. There's just so many windows open everywhere. Let's just get rid of everything. Okay, something about like simple appearing somewhere. That may have been the static files itself. Okay. So this says fractal.wasm, which is fine. I can't. Web stuff is just so unnecessarily painful. Why is this saying like directory when I'm launching this HTTP server here? Let's just like continue to clear these caches. Oh, because we're not launching it from within. Zig out. Yeah, get what like where's this happening? So normally I just say grep simple.wasm. What is it like on Windows? It's like get string. No. We can check what appeared in the output. Okay, yeah. So this, why did it think this is simple? Yeah, why did it not just copy the stuff in the other one? Oh, because it's copying it from here. Yeah, no, we don't want it to be copying it from here. Oh, I see. Right, okay, so this static here, we're gonna want to replace. So let's actually move the static here to like static delete. And instead, this should be rainbow triangle / static. Oh, yeah, if there's spam. There's spam we need to get rid of. No, where's like the dashboard? Let's see. Look. Best viewers. Okay. Oh yeah, because hang on. Let's instead of just going between these repeatedly, let's put zig out bin. We're getting another fail. Let's just clear the cache again. Okay, another file not found. But fractal wasm. Okay. So it's still, okay. It's now saving it as rainbow triangle, which is good. That's what we told it to up here. It's just that the static stuff that we're getting it from, we defined it as something different. Okay. Maybe it would be good just to like save this as a string somewhere that gets inserted into this. Like it should very much be possible to do this with the build system. We can just have a, this entire thing can just be like a string, and then there's just like brackets here, and then we just do the zig, like even at the compile time, like compile, calculate the entire string, then save it out to be a file. Might do this later. And now we'll just do this. Kill that. Build it again. Launch it again. This is maddening. Okay, finally. Okay, so now we've reproduced this, but now like properly, we can now remove the static, delete, remove anything, let's just clear everything, remove this weird dash thing. I don't think we need the source either. Yeah. Port sliding puzzle source. Okay, I think that's almost all we want at this stage. Okay. So now we can yeah, we'll set this up as a new Git repo and then start saving it. Nothing here yet, which is fine. I swear that like last time when we tried to like, when we like made something from GitHub like with the license first, there was just like a lot of pain in trying to get it to work. So I think we pushed this to GitHub and then we determined the license. From memory, that's what we did. So yeah, so we want to do git commit. Yeah, started reporting the puzzle game with Zig, with the Zig JavaScript bridge library. And the fractal example. Okay. So now let's create a new repo we'll just have like a new repo, and then maybe maybe at some stage we like merge this with the original thing we did, but we'll just keep things separate for now. So we want to do a new repo. We should give this like a proper name. So like sliding puzzle. Or like sliding puzzle in Zig Wasm, or like sliding puzzle. Oops, wasn't I like? Why don't we call it sliding puzzle in Zig Wasm port? Sliding puzzle in Zig Wasm port. Okay. So yeah, our simple sliding puzzle puzzle made in Zig, but now ported to Wasm via Z JavaScript bridge. So yeah, let's make this. And then we want to, I already did this one, yeah. Copy that, and then, yeah, git remote add GitHub, GitHub host, GitHub servers, the name of it. We already are on main, right? Yeah. I git push you GitHub servers main. Okay. So now this is here. Good. And so now I want to add in the license. Button admin happening. This is so painful. We did this last time. We've already forgotten. I guess we'll have to do it again. GitHub make a project MIT license. How do we do this again? I also I love Kage that it's like on medium.com someone's like how to license, and it's like $. You must pay to find out how to make your projects free. Yeah, everyone knows. Okay. I'm gonna do this one, right? Okay, finally, here it is. This UI changes so much. Select add file and then create new file. This one? Okay. Different from the documentation here. Okay. In the field name, type license or license.md in all caps. Choose a license template. Okay, we'll just discard these changes. We want the MIT. This is the one that Scott Reedy was using, right? Yes, okay. Click review and submit. Yes. Then commit changes. Yeah. Added MIT license. Okay. Okay, great. That's now added. We should actually, we're gonna be coming back to that page a lot. We should save it. License. Start this. GitHub license. Okay. So now when we look at the repos, it should have MIT license. Good. Okay. So yeah, we need to like next stream we'll do a similar thing and update that. But yeah, for now, I want to go for a run in an hour's time. So continue programming. Yeah, so now we can actually get on with the actual programming and start rendering a rainbow triangle. It took so long to get here, my goodness. All right. So, so where are we going to begin? We can begin with the shaders. So I would imagine here that the shaders we have are really simple. Like the fragment shader will be a bit more complicated since it is making a fractal, but it's still like 30 lines. Okay. Oh, was this like precision medium float? I do not remember that. Oh, this is like specifically alright, this is a web OpenGL thing. Learning WebGL tutorial. Oh, so this is like, is it using 32 bits or? And stuff. We will see. We'll see if we can avoid having to look up a WebGL documentation. We'll see. Okay, so yeah, embedding our files. Timestamp is an F64. This is different from our sliding puzzle game where this is an unsigned 64. How is this working? We might come back. It's short enough, look, we may as well just read through the entire thing. Okay. We have a generic log function. zjb.global console. Okay. Alright, console must be this thing. That's right. Yeah, if you want to call any JavaScript function, you have to like tell. That's like where to do it. This is the name of the function, and this is like the function args. Okay. Okay, and then we're getting handles to the GL context in the shader program. Okay, and then this is this like get element by ID, find the canvas. Okay, and then okay, already setting it to 500 by 500, so that's good. And then I think that explains why when we uploaded to itch it fit perfectly. And then get context web GL. Okay, all of this is still like setup stuff. I doubt this stuff is going to change. We might have to look up the WebGL documentation again, just to well, if it's working like this, should be fine. Okay, here's like another specific one. Get that. Timeline.get. Oh, it's like get the thing that you use to like look up like the, is get like the method call or something. I think so. Okay. Then it must be in milliseconds if we're dividing by 1,000. Okay, init shaders, that's good. An animation frame starts this. Okay. Getting a bunch of constants. Okay, create shader, a vertex, turning a handle. Tell it where the source is. So this is embedded within the Wisdom file. It's just like the string, and then so we're getting this via zjb.string. Why not like constant string? Wasn't that also an option? Yeah, or I felt like did we see that in the documentation? When I had like the difference between the string and the okay. Yeah, kind of surprised this isn't a constant string here. But okay. Okay, and then yeah, like gl.create shader, yeah, that, where it is, and then compile it. But we're not doing any error checking yet. Then similarly set up the fragment shader. Yes, and then we're creating a program, shader program, but we're not passing anything in there. Interesting. I guess maybe that's just the API. Then, well, then we're attaching both and linking them. Okay. Otherwise it failed. Okay, so so if we were to actually go into the zig build rainbow triangle, we should be able to see this when we run it. Oh, I wonder if on like itch dot if on itch we could, if that appears. It does. We do end up seeing this. Curious. Okay. Skipping unsupported feature name. Monetization. It's monetization appears several times. Yeah. lib.min.js, whatever that is. Okay. So the stuff we do call does end up there. Okay, so this will be really straightforward to. I was gonna say this is straightforward to adopt, but now I'm less sure since strictly speaking, to the compiler, we don't need to tell it where the attribute information is, but we're going to have to do that at some stage. Especially since we're taking in a uniform here as well. We should have what the type of this is. This is an F64. So last timestamp seconds and last timestamp. I mean, yeah, it is above, but like, it doesn't hurt just to say it again. Move these to global variables grown. Why would we be moving? Oh, I guess we'd be moving them to global so we don't have to call them as many times. Is that right? Yeah, this would make sense. I could see like during setup, like all this stuff should be known. Like, like in some sense, all of this stuff, I wouldn't expect this stuff to change, even if this is like WebGL. And so I could see we actually just declare these things to be constant, and then we don't have to ask for them during like runtime and query them then. But I guess in the absence of that, this is what happens. Get the position of the attribute a vertex position. So the usual call is gl.getAdd trib shader program a vertex position. Okay. I'm wondering if there's memory leaking if we're getting this several times. We should actually look up what the library's doing. So yeah, we're passing in a constant. It's producing a handle. Okay, I guess this is fine. Yeah, this isn't doing anything unnecessary with, this isn't doing any memory related things, which is good. I don't know what this const handle stuff is though. But we could call it a const string since we are passing in the string at compile time. You know what it is. It's this get const handle. In from enum string b. Okay. Yeah, I don't see why we can't make this content. That was similar for some of these other ones up here. The JD.string. So yeah, let's try compiling this and then running it again. It's always, should we have this in a different window, I guess. Okay, yeah, this is fine. No active linked program. So yeah, all of the time when we know the string in advance, which is pretty much everything, we can just return a const string instead. Said JV dot. Except for the log string, that one we don't know. Okay. Yeah, with all of the caching and stuff that's going on, I'm always worried that something's just like working because it worked last time, but it's currently failing. But I guess this is. Okay. Yeah, it seems to be fine. Okay. Even the core function within the dependency. Fn core. Yeah, these are expecting a const handle anyway, so yeah, that's good. Which the const string should be returning. Yeah. Position buffer, create buffer. Okay, and then okay, this, I guess this is slightly different from OpenGL. So jb.dataview positions. What's dataview doing? I don't want to read it there. It takes in any type and returns a handle. So we're giving it a fixed array. And it's switching on the type of it. So if it's a pointer, which in this case it is, or if it's not a pointer, it's gonna fail. Since data stuff is comp time known, we're going to catch this at comp time, which is good. And then depending on the pointer size, return the data size of child/data. So what's it actually returning? Okay, any opaque and a handle. it's doing it in bytes. Pointer.child. Okay. Okay, and then we actually get our buffer data call. Oscillating value. Okay. Okay, then here's all like the expected GL calls. Clear the color. We'll set the clearing color, then do it. Clear depth. Okay. Enable depth function. Okay. Clear. Don't know why there's so many of these. Color buffer bit and depth buffer bit. Yeah, isn't this like a repeat of this? It looks like it. Otherwise, it's almost the same. The vertex position, which is what? Okay, finding what that is, then number of components, type, don't normalize it, the stride and then the offset. Okay. What about the overall length? I guess it doesn't. Yeah, why is the stride 0 here instead of 2? Strikes me as really weird. Okay, and then we're setting the time. Slightly weird we're able to do that before calling it there. Offset vertex count and then the actual drawing command. And we're saying draw this in a strip. Okay. Oh gosh, I already feel exhausted reading that. Okay, so if we want to turn this into a rainbow triangle instead, what are we going to have to do? We're going to have to change the vertex attributes, like we can pass in the position and the color. First of all, how does that work? And then once we've got that, we'll then need to pass it into the fragment shader somehow as well. We'll be able to get rid of, we can keep the uniform in here in order to rotate the, I was going to say keep the uniform in there to rotate the triangle over time, but I think it's way better if we do that within like the zig, within the zig safety net. So within the zig WASM, we will rotate the triangle and then push the data to the GPU. It's rather like push the data out of the WASM into the browser, then the browser itself pushes it to the GPU. It's so silly. Like, games are not meant to be played on the web. You're meant, like, the CPU is meant to be able to go, this is where the data is. Send it to the GPU immediately, not pass it through all of these different abstraction boundaries and layers. But anyway, I digress. Okay, yeah. Okay, if this is just pure OpenGL, like clearly we know what to do, but it's rather this like, we're gonna have to look up an example. Yeah, this one did look interesting. Of course. Oh, it's not generated live. We are avoiding, this is why we're not doing it. Okay, so they are doing some init buffer stuff. How are they doing this? It's like, it's so bad, like what even is the data type of this? Like, presumably this is a float, but technically it could be like an integer, it could be like a byte. Is this like, is this a slice? Is it just like a fixed array of 9 elements? JavaScript is such a terrible language. Okay, and then, what is this making memory for this every time? Okay, this like a sentence like this is like no. No, we want to see like, we want to see an example of like stuff being passed between the WebGL vertex shader and the WebGL fragment shader. When do we get to that stuff? Oh, now there's like matrices being called. Oh gosh. Yuck. Get shader. Like this is so like. If shader script.type equals disaster. Okay, lesson 2. Okay, here we're getting to the stuff. Oh, we have to call like varying. Okay, so I guess varying is how you define what something out is going to be. But then you need to define the attribute in the next one. Or you just call it varying again. Okay, I guess WebGL then knows that there's just some like symbol associated to this, and then in the pipeline it goes, you're gonna have to assign that to that. Okay. I suppose there's a way we can immediately test that. So instead of assigning this to the GL position, we can we call this like vpos, and then the claim was what we typed is varying vec for vpos, and then okay, and then we also wanted to say varying the pos here. Do we need to presumably each time you need to tell us the type? Yeah. Okay, so then when we do the position stuff here, the GL frag coordinate, this should now be, oh no, what even is the purpose of this? We're passing in like, to me this is saying like figure out the pixel and then do stuff based on that. So why did we need to even pass in this stuff to begin with? It does need to know the position. Okay, in either case, okay, we'll continue. Like, yeah, position must just be like the normalized coordinates of where you want the vertices of the triangles to go. Okay, so here is doing a vertex and color example. Okay. Like, that's all correct, but it's... Yes, let's create a function called rad2degrees. I'm sure JavaScript will inline it. Oh wait, it doesn't, because it doesn't compile stuff. Okay. Yeah. I think all we really needed to figure out was that it was, you just call the thing varying, and that's it. Visit movement. No, we know how to animate this stuff. Okay, so here we're saying curl as a dog cat. Oh, so here they're like creating two different buffers. Instead of just like a single thing and then finding stuff from within that. No, I don't like that. What I want to do is modify like the -1 and 1 values. Instead of calling this position, call this like position and color, and then we just say like the stride is 4 and then the offset is like 1 in, for one of the cases is 1, and then for the other case it's like 0. You know, I just check this out. WebGL vertex attrib pointer. So I still find it so weird that like why is this right here 0? Like why is this not, why is it not an immediate fail? That's not that. Why is it working? Okay, if the stride is 0, the attribute is assumed to be tightly packed. That is, the attributes are not interleaved in a separate block. Oh, okay. Like we should be able to set it to 2 and it would still work, right? Oh, wait, what's it? Is it? All right, it's the offset in bytes. So, okay, so if we said this is 2 times its size of F32, this should still yeah, it should. We would expect this to still run. Okay. So yeah, Python launch this. Okay. Yeah, so it's something failed. I'm like, we know exactly what failed in this case. But just in case. Yeah, okay, so why Why does actually specifying the stride instead of setting it to be 0 make it fail? Number of components per vertex attribute. So this just means like we're doing 2 floats, right? Yeah. Let's see. Okay, it's nearly 6, so we should get going soon. Yeah, I'm surprised this is failing. Like, am I missing something? For the actual sliding puzzle. No, it is like two times the size of this. Are we like failing to enable this as an array? No, surely we are doing it. Yeah, so why is this failing? Does it fail if we just set it to be like an 8? No, yeah, not liking that. Do local Oh no, something's really off now. Like what? Yeah, something's really not right. Yeah, why is this, what's happened? Why is this no longer rendering? No, so like when did this fail? No active linked program, but it is. Oh no. Like I felt like what we really did was just read through this. We changed some things to be like constant strings, but that was it. Right, like if we just do oh, we did change the shader a bit. Right, that must be why. Okay, so if we actually change everything back to the constant strings, I totally forgot we did that. Wait, I think we can leave this as 8 for the stride, but rather, let's get rid of the varying here. I totally forgot I did this. And then likewise we want to get rid of that, and this is the same. Okay, so now if we sig build rainbow triangle, and then run it from here. Let's just reset everything. Quit it all. Keyboard is bad. I need to get another one. Sig build range build zig out bin Okay, we're back to normal. Oh, this stuff is so painful. So painful. I remembered it being easier than it is. So I'm almost now like backtracking on wanting to port this. We'll push on with it. So let's change this to an 8 and see if this fails it. Okay, presumably it's still okay. So I guess we could. What's one way to like one way that would like ensure this fails would be to but we could do something like really weird by like making the stride like 4 instead. And then yeah, we'll see what happens. Okay, good. That is what we expect. Okay. So now we can set up 2 times that size of F32. Rebuild that, launch it again. Okay, good. Okay, so we're like, I feel like we're close, kind of. So let's say we did want to add in these colors, then it's doing some like weird. This was doing some like triangle strip thing that I don't like. WebGL triangle. Is it called triangle strip? Yeah. I guess we went with this like the first time just to get something rendering on the screen. But we want to now just like draw it triangle by triangle and not link them all together. Where's like the... Oh, okay, this is a useful this is a great website. This is what people want to see. Okay, so yeah, we should be able to replace this. So triangle strip. Let's just replace this with triangle. Triangles, plural. GL triangles. What's this vertex count? Oh, that we can do better than this. We can do a lot better than this. Z can calculate this for us. We're not like JavaScript, which presumably has to like calculate this at runtime or something. We can figure out what this is at compile time. So we want to, so this is just going to be, the vertex count is positions dot a length divided by the stride, which is 4. Or actually, maybe it does make sense to just call this 6. But we can, in here we can make this, we'll make this 6. Well, 6 times 2. Okay, and then why do we need to pass in an offset when we're doing draw array? Surely it's just, oh no, this is like OpenGL. Start at 0. How many are you drawing? Okay, so then if we want to draw this at each of these triangles separately, then we want so we're doing 1 1 -1 1. This is so weird. So we're saying top right, top left, bottom right. Okay, and then top right, top left, bottom right. So we've done the top left one. So then we just want to do top left, bottom right, and then bottom left. Oh, it is another way as well. Okay. Oh yeah, we've already done that. So now build it again. Move it here. Launch it. Okay, that's fine, presumably. Okay, so now if we let's add in some like dummy data that we're going to be filling with the color data soon, or maybe next stream. I don't want this to be a line zig. Positions doesn't feel right. Okay, and then we would expect this to give us something weird when we compile it. I'm still just trying to get a sense for like when exactly will like Firefox refuse to like update the cache, etc. Okay, that's what we expected would happen. That's good. So then we want to update the stride here, well, both of these. So now the stride is every 4 floats. And the offset is 0, but we're calling 2 of them. Build that again, get that working. Good, okay. Okay, I feel like we're nearly back in business. So, yeah, so in order now to get the triangle strip is gone, we're just back to drawing triangles the regular way. We're now no longer drawing stuff in a packed way. We're just actually saying this is where you get the data from. Here's a point to a bunch of floats. This is where you get stuff from, and then yeah. So now it's just a matter of changing these zeros to well, really we're going to want to pass in. Well, we're going to want to set these to colors ourselves. So we're going to have to kind of remember what the colors are. Maybe in this example, when it's just this regular triangle, we'll set them up, we'll fix them, but then when we port the sliding tile, we'll do, I mean, then we have the system set up and we kind of know what to do. So just to remind ourselves, this is top right, top left, I think, bottom right. No, that's like, yeah, that's bottom right. So then this is also top left, bottom right, and then bottom left. Okay, so if we make like, oh, we can now like start, yeah, we can now just like draw the triangle. So, it's really time to go for a walk. Okay, so since we're like drawing a single, what am I doing all of this? We're drawing like a single triangle. So let's just call this like triangle GPU data. So to begin with, we'll just make this 3 lots of 5 vertices. Well, I can just specify it in this way. So then, yeah, we want to do, oh, okay, we're going to need like a couple of square roots. So square root of 2, luckily because of comp time, we can just, what we can do even better. Square root of 2 is just there. This may actually be in the standard library. I think it is. Let's check. Zig square root 2. Yep. Within math dot square root 2. Okay, so okay, what are going to be the coordinates? So yeah, if this is like, if we're drawing just the equilateral triangle and we're drawing the coordinates in a sensible way, we want, maybe we have red as like the first coordinate, and then For the next one, we're going to have to go, I guess it's negative. Let's see, the next one's on like an angle of 30 degrees from, I feel like it should be somebody's telling me it's like, it's negative 0.5. I think intuition tells, like, I've done these calculations enough times that I'm pretty sure that's what it is. And then this one will be like 0.5 times the square root of 2. Maybe Zig may not like the fact that it's being casted in a different way. Make it an F32. 0, make that, say, blue, green, and then make the last one blue. And then, yeah, we'll just get rid of that. So now we're saying, it's kind of like a constant data view, but it's fine. Triangle GPU data. We're going to have to adjust the attribute arrays a bit. So it is still 2, but now the stride is 5. And the vertex count here, well, now we've just got 3. So, yeah. Okay, so let's try and compile this. Oh, good thing we're finding out there's an error. At compile time instead of at runtime. Doesn't know what square root is. Okay. We would have thought type checking is really powerful. Well, it's not really technical. It's more just still like syntax stuff. Okay, cool. And now we've got basically a I have to look again at like the square root of 2, but I think it's plausible that this is okay. No, it's not. I would expect this to they're setting, no, I don't, why are we setting it to 1? Because it's on the unit circle, but, wait, let's see. So if we're doing it at that angle, then yeah, the height will be wait, I think it's meant to be the square root of 3 onto I'm not sure if this is in the Zig library. I guess we'll see. It doesn't know. That's all right. We can just Oh wait, why am I doing that? We can just there's an intrinsic for it. We'll figure it out. Unless it's gonna complain that it doesn't know what the type of it is. Okay, that's better. That's, yeah. We are a bit of a trig error in our brain, but this looks now correct. This now looks correct. Okay. Yeah. So now we have the background's kind of. I don't like the background oscillating as much as it is, but I think this is a fine place to stop now. Yeah, next time we can begin to we'll replace the fragment shader with one that like reads in the colors from using like what's the syntax? It was whatever the syntax was, like varying or something. Into things called varying variables. Like, yeah, like like a language is of quality when like the thing it says is in its name. Like scalable vector graphics. Yeah, last time I checked, vectors were you could always multiply them by a scalar. So why use it's like saying like the water vapor clouds. Yeah, no, of course. What else are they made of? Anyway, varying variables. Yeah, next time we'll get the triangle oriented in an appropriate way, and then once we've done that, we can then add that back into, like now that we've got this, now we've set up all of the back end. I say like back end, but it's now there's a legit license in this. Now there's a .zon file that like now the dependencies are like in a correct way. Next time we might actually just completely clean, like once we get the rainbow triangle working, we'll add it back into the WASM thing. GitHub.com. We'll get it back into, no, what is it? Get it back into the WASM examples, and then like, yeah, this is in desperate need of cleaning up. Yeah, it's under clean that up, and then finally once that's done, we'll then get started on porting the file. But yeah, until then, thanks everyone who dropped by, and yeah, it's God, all of this web stuff is so painful, but but as we found when I was skimming the JavaScript documentation, JavaScript is better in Zig than in JavaScript. So see you later. Bye.